Chain rule part 2. Here's an interesting question that we can solve using the chain rule. In the part 1 video, I gave you 2 methods for solving those problems. The easier method was just substitution. For this problem, we can't really do substitution because we have z as a function of x and y, but we don't know what the function is. So we can't just substitute. We have the x and y functional relationships established, and 2 partial derivatives are given. We're looking for these 2 other partial derivatives as unknowns. So here's how we're going to do it. First of all, we want to write out a tree diagram. Z is a function of x and y. X is a function of u and v. Y is a function of u and v. And then let's write out the partial derivative relationships. Partial of z with respect to u is partial of z with respect to x, partial of x with respect to u, plus partial of z with respect to y, partial of y with respect to u. That's 1. The second partial derivative relationship is partial of z with respect to v, and we can do z sub x, x sub v, z sub y, y sub v. And now substitute. This is a good rule in applied math is that the problem students have sometimes, they look at a problem, they try to solve it. Well, that's a backwards way of solving things. You should look at what's given, what can you write down. Well, if you have this multivariable relationship, first of all, you can always write these formulas down. And second of all, you can always substitute. And let's see what we know. Partial of z with respect to u we know to be 1. Partial of z with respect to x, it says find, that's an unknown. Partial of x with respect to u, we can compute that, that's 1. Partial of z with respect to y, that's an unknown. Partial of y with respect to u, that's a 1. Okay, well, guess what? We have an equation. Okay, over here, partial of z with respect to u, or v, that's a v, sorry about that, that's equal to 0. Partial of z with respect to x is unknown. Partial of x with respect to v is 1. Partial of z with respect to y is an unknown. Partial of y with respect to v is -1. There's a second equation. Guess what? We have 2 equations, 2 unknowns. It's just a matter of solving them. You can solve and substitute. In this case, we get partial of z with respect to x is equal to partial of z with respect to y. Just move that over to this side, and you can substitute 1 equals partial of z with respect to x plus partial of z with respect to x. Pretty easy to see what's going on here. Partial of z with respect to x is equal to 1/2, and since that's equal to partial of z with respect to y. And we really have our answer there. So it just comes down to 2 equations, 2 unknowns. So that's all for this video.